So the next topic that we're going to be discussing is called alkene reactivity. So the setup for this reaction is going to be obviously an alkene, and we're going to have that alkene reacting with a hydrogen halide like HBr. So this is what's going to be variable amongst all of our different alkene reactions. So we don't always have to have an alkene react with HBr, but this is just one instance where it's able to. So the combination of the HBr with the alkene is actually going to yield several things. So this is what's going to happen after you combine your alkene with your HBr. And you'll get this product on the right. So it's obvious that the combination of the HBr resulted in several things. First, you're going to see that the alkene has been converted into a different functional group. It's now an alkane. More on how this actually happened in a second. We'll talk about this more later. The second thing that you see is that it's pretty obvious that the bromine that used to be part of the hydrogen halide has now been covalently attached to the molecule that used to be an alkene. And so now, instead of that bromine attached to a hydrogen, it's now attached to a carbon. So right here it's attached to a hydrogen, now it's attached to a carbon. So now we've made a new bromine to carbon bond. Again, we'll talk about exactly how this happened later on. But there's one other thing that's happened to the original alkene. If you compare and contrast this original molecule on the left to the final molecule on the right. A question is, where has this hydrogen gone to? It used to be attached to the bromine, and now obviously it's not attached to the bromine. We have to still have it somewhere. We can't just destroy it, so we have to conserve that hydrogen somewhere on the right-hand side of the equation. Let me go ahead and label the original carbons on the molecule as 1 and 2. And if this carbon is 1 and this carbon is 2, it's pretty intuitive to say then, well, okay, then this carbon is carbon 1 and this carbon is carbon 2. If I asked you, where we attach the bromine to, which carbon we attach the bromine to, it's pretty obvious that, well, we attach the bromine to carbon 2. So now let's go back to this question of, well, what happened to this hydrogen from the HBr? So one way to answer that is to think about how many hydrogens were on carbons 1 and 2 originally. And at this point, hopefully it's very obvious that originally there should be 2 hydrogens on 1 and 2 hydrogens on 2. That should be something that is very apparent and should come to you very quickly. If not, more practice is needed to talk about implicit hydrogens. If we know how many hydrogens were on 1 and 2 before we did our reaction, the question then is, how many hydrogens are on 2, on the carbon 2? And at this point, it should be obvious that we have 2 hydrogens on 2. And so these 2 hydrogens right here were from the original molecule. And so how many hydrogens are on carbon 1 after we've performed our reaction? We have 3 implicit hydrogens, 1 here, 1 here, and 1 here. So these are all on carbon 1. One question many people have is, well, why aren't there 2? There were 2 here, why aren't there 2 here? Well, the reason we know that there aren't 2 hydrogens only on carbon 1 is 1 charge. So the way that I've drawn this reaction, I showed the molecule on the right. The molecule on the right did not have a positive or negative charge. And if we had drawn the molecule this way, we would know that carbon 1 would have a positive charge because of formal charge calculations. And again, these should be something that you're getting more comfortable with, and you should be able to do them very quickly. So now that we know that carbon 1 doesn't have a positive charge, it must need something else bound to that carbon to prevent that carbon from having a positive. And so if we don't have a positive, we don't have a negative, in the way that I've drawn it, we haven't drawn any other explicit atoms attached to carbon 1, the only alternative is that we have to have a hydrogen on carbon 1. More on how that hydrogen was attached on carbon 1 in a moment, but just to kind of reiterate what's happened. So this hydrogen right here, this red hydrogen from the HBr, that red hydrogen ends up being translated over to carbon 1. And so we've made and broken a bond. We've broken that old H hydrogen to bromine bond, and we've also made a new bond between the carbon 1 and the hydrogen. And then also we've made another bond. We've made a new bond between the bromine, this yellow bromine, and carbon 2. So notice that if you try to backtrack, you see the hydrogen and the bromine that used to be within HBr. But now you can see that for this alkene reaction, the one carbon that used to be on the carbon 1 gets a hydrogen, and the other carbon that used to be carbon 2 gets a bromine. And so both of these carbons that used to be on an alkene get a new covalent bond.